sound check. Test 1 2 3 check. Sound check. Test 1 2 3. Sound check. Testing 1 2. Sound check. Check 1 check. Sound check.
Hello, hello. Hey, hi everybody. Hi. So I'll give you a. So welcome to the React conference. I believe most of you have been frequenting these React conferences earlier as well. I hope this one is as good as some of the best experiences you had so far. My name is Ed. I have Shivam Kumar with me. Both of us are MTS, member of technical staff at DevRev. Both of us primarily work on Frontend, and we are really happy to host all of you today. To give you a brief idea of what DevRev is, what it does. So DevRev is a AI native platform that brings together all the possible quadrants as part of a software release cycle, product planning, support, management, operations. It brings all of them together under one umbrella. And the idea is to kind of get rid of the incumbents with our AI first approach. So yeah, that is pretty much it. We will, if you guys want to discuss a bit more about maybe what DevRev is, or maybe career paths, trajectories, how you would want to grow in a career, whatever that may be on your mind, feel free to reach out. We'll be here somewhere around the corner. And yeah, if anybody has any questions, you can take them now. But otherwise, we can get started with the meetup. Okay. So we have Shrivant with us, who is going to be.
Show you how to build virtual reality websites in React.
Cool, cool. Anybody excited? No.
Yep, so okay. So hi everyone, I'm Shrivant, and here's a little something about me. 1 second. Okay, so I graduated this year in VIT Vellore, BTech CSE, and I'm currently working with Volvo and Eicher. So we develop fleet management solutions. So like if you buy a truck, we can track it, and we can mobilize it, we can immobilize it, some cool stuff like that. And then in Volvo specifically, I'm in the commercial vehicle industry, and that's my GitHub link, and that's my LinkedIn. Maybe I'll share this slide with you later, so it wouldn't be a problem. Okay, so today's agenda. So I'm going to tell you what Spaces VR is and how we are going to use Spaces VR to build React virtual reality websites using React. So there's going to be an introduction to Spaces VR, the package, and then we're going to set up an VR environment, add interactivity, React integration, and then we're going to talk about the real world application. So sounds good, right? Okay. So Spaces VR. What is Spaces VR? Spaces VR is a very lightweight package. So it's basically just npmi Spaces VR and you're good to go. Spaces VR is built on, it's like a skin on top of, React 3 Fiber, 3JS, and React 3 Dre. So they provide their custom hooks and custom components. Spaces VR uses those components, and they create your own custom components. So it's more easier for us, like to asynchronously load 3D models which you download and stuff like that. So the goal is very clear, like making virtual reality websites, like developing them as easy as developing traditional 2D static websites. So that is the goal of Spaces VR. And Spaces VR is maintained by Muse, a company. Okay. So let us start. I mean, if you have your laptops, maybe you could join the live coding session with me, but if you don't, it's not necessary, you could do it. Okay, so the first step is just create a basic React app and clone the repo from either my GitHub account or Spaces VR's GitHub. So wait, let's do that. Wait. Okay, so there's a QR for the GitHub. If you want to scan it, you can. Okay, so is there anyone left to scan? I can start, right? Okay. Okay, so let us start. So you can see my screen, right? So this is it. To this in a second, like what all these are. So before that, let me just run this project and show me what it does. So first, you just make sure that your node is greater than 20. Let's yes. Okay, fine. Are you guys able to see the code? Okay, fine, right? Okay. I'm using a white configuration. Okay. So this is the starter pack. You get this. You control it like you're controlling a video game. If you have played Cyberpunk or GTA or anything, Valorant, WASD, and if you have a mouse, you can control it with your mouse. So yeah, this is it. It's a playground where you can download any 3D model, do anything you want here. You can even create a first-person shooting game using React. So let us place this aside for now. So the first thing is it's an empty space, right? So it's an nothing is present in the ground or in the sky. So let's add a floor to it for now. So if you want to add a floor, so wait. So this is going to be our final destination. We're going to want to reach here. So let me tell you what each of this code does for you. So I'm going to import loader. From React 3 Fiber. This is used to, load 3D models asynchronously because 3D components have so many mesh components inside them. So you want to make sure that everything loads and then it renders in your screen, or else it's gonna be jaggy or no, not proper. And then we have, okay, this is not required for now. And then let's import our textures. Okay, that's also not. Okay, yep, now we're good to go. Now, let's create a ground texture using use loader, and then let's have a plane. So plane is nothing but a 2D rectangle for your 3D environment, because you need a 2D rectangle for placing the ground correctly. And okay, now we have to import plane from React 3 tray. Okay. Okay. Yep, this is good. Now let's just add an args. This is to define the size of the plane, and it also takes some rotation as props. Okay, so make sure the plane is like this initially, so you want it like this for the ground to be flat. I'll show you if it's not, what if it's not flat also. And I think that's it, right? Plane, rotation, position, okay, that will come later. Okay. Bug. We have a bug. Texture loader, okay. You have to import texture loader also. Texture load minus. Okay, reload. Yep. We don't, okay. We need use texture loader. Okay. So as you can see, it's lagging, right? That is because our plane is at the same level as the base ground that spaces VR provides us. So we're going to have to change the position a little bit, slightly. The y-axis should be slightly above. So position and the y-axis, right? 0.1. Let's do that. And now we have our ground here. So you can move. But you can see that this is not proper. It's very pixelated because this is one whole HDRI JPG image. So what if you don't want it pixelated? You want it proper. So we can tile it. So you have like tile spaces, right, at your homes. So let's tile it. For tiling, you're going to just want to do this. And see. So what this does is, it wraps the horizontal and wraps the vertical, and it repeats the wrapping, and you can set how many ever tiles you want. I set 100, 100. Now you have to import repeat wrapping also from 3. Okay, now you have a proper ground. Now you can move around. And you see it's not pixelated, it's clear, it's like you're walking around a road, right? Okay. And you could change it also. Let's change the path to grass. Reload. And now we have grass. So I personally prefer grass over crack, so I'm going to go with grass. Okay. Now, next step, let's add a first model, okay, a building for our space. So in the public folder, I have downloaded some models for you, desk.glb, mark85, and we also have buildings, so VR showcase class. So let's import model. Okay, from spaces VR, and then let's use it in our code. So model, enter, and you can specify the path, source path. Okay, yep, and that's it. Reload. Where is our model? Okay, you can see it's a building, but it's too big. So you can't make of what it is. So we're going to have to adjust the scale of it. So let us adjust the scale. Scale, let's give it 0.05. I know this because I've done it before, like how it should look. So we have our building now. You can move inside the building, but it's not proper even now. It's orientation. See, the window is supposed to be on the top. Okay, so let's adjust the position of the building now. Position. Position, okay. Not the position, the rotation. Okay, so minus math.pi/2 is nothing but 90 degrees. So you're going to rotate it 90 degrees around the x-axis. Now you have a proper building. You can move around. You can see there's the window, there's the pedestal where it's supposed to be. But now you could see the ground is grass, but the ground is not supposed to be the grass. It's supposed to be the proper ground, whatever is there for the building, right? That is because we set our ground's position slightly above the base spaces VR ground, but our building is in the same position as the grass thing. So we have to position it slightly above our custom ground. So we'll do it 0.2. Now continue. Now we have a proper room set up, right? Okay. Now what else should we do? Let's add an background to our environment because I don't like white. So for background, we're going to use HDRI. And HDRI, you're going to have to import from spaces VR. HDRI, yep, and S. Now load, go, and there you have it. You have a environment for you. You could download any HDRI image you want from the internet, and you could have whatever background you want. But still, now you could comment this lost world. You don't need it anymore. Now it's proper. Right. Wait, let me reload. HDRI is just an image. In spaces VR, they use it to do the background 360 degree. It's not moving around with me. I haven't explored that. It's new for me too. But this is what I could do. Okay. So now you have this. So now you set up an environment. You set up the ground. Okay, it's dark. That's why you're not able to. Let me increase the brightness. This is the maximum I could do. Okay. Okay. Let me change it back to crack. Okay, it's even darker now. Okay. That's what. Lightings are gone. Okay. And let's change it to grass only. Okay. So now what else shall we do? Let us import an Iron Man armor model inside our building. Okay. Okay. For that, I'm going to want to install a package called gltf.jsx. So what gltf.jsx does is it auto-generates a JSX file for you, because now we have a building that we just specified the path here, model. But inside this model, we have so many sub-models, like meshes, like the door is a model, the door handle is itself a model. So it's like a div inside a div inside a div, React terms. So, but what if you want to access the model? You want to specify the behavior for a door. Like you want to say, if I click on the door, it should open. If I close the door, it should close. Something like that. You need more configuration to be done, right? So you need a gltf.jsx. So the terminal, you just cd to the folder where you have the GLB file. This GLB file or the files are the 3D models basically, and you just do npmi gltf JSX, and this should install the gltf JSX package for you. And then it's already installed for me, so I'm not going to do it. And you want to make sure your node version is greater than 20. Okay, nvm use 20. Okay, and now you want to do npx gltf JSX and m85, the name of your model .glb. Enter. Now you can see auto-generated file. It's over here. See, this is the auto-generated file for your 3D model. Now you have this group mesh. Now you could access everything. This is going to be a trial and error part, because even I haven't figured it out how to know. But you see this gold part and everything, the armor things. So you're going to have to figure out like which part is which by changing its transparency or color. You could do that. But now, for now, we're going to just stick with this, and we're going to export it by default. Export default function model, and we're going to use it in our project here. So import model from dot slash m85. Yes. Okay. And now let us use that model in our code. So for that, what we're going to have to do is just do m85. Okay. That's it. Minus. Now let's go back to our project. Okay, we're not running it. PM run dev. Okay, okay. Okay, two models. Okay. Yeah, different name, right? M model. Oh, okay. No. This was the issue. Model. Now reload. Okay. So now we have our Iron Man armor, but it's too big here. So we're going to have to adjust the scale of it. So if you want to adjust the scale, you can pass props here in the first group. You could just say scale props dot scale, and position will be props dot position, and that's it. Here you could do scale equals 0.1. Nope, let's do 0.5. Okay. Now let's see. Up smaller now. Smaller, but I need it even more smaller. So 0.2. Continue. Yep. Now it's better, right? But the position, it's overlapping with the pedestal. So let's move it a little right. Position. So let's see what position I have given here. 0.2. Commanders. Refresh. Okay. Yep. It's moving a little. Okay, this is the y-axis. Now let's give it the x-axis. Okay, it's stuck to the building. 1. And let's change the z-axis to 1, 2. Continue. Yep. Now it's all right. Now it's somewhere that we can see it is. So this was just a base of what you could do with Spaces VR and React VR. Now I'll show you what I have done. So let me just check out main. Okay, and let me show you. And let me also cd to my backend. Okay. Okay. Enter full screen. Continue. Tab. So yep, this was my environment. So added this small green button called open the door, close the door. Okay, you're not able to see it properly, I guess. Okay, but still, you cannot enter if it's closed. Now, if you do this, you could open, and there's your model. Now, there's no Iron Man without Jarvis, right? So I have here with me Jarvis in 144p. So let me click on Jarvis. Let him start listening to my commands. So I just say explode, and you can see the mesh components have exploded. And I just say assemble, assemble. No, it's listening. WebKit, damn you, WebKit, speech recognition. Assemble. Yep, yeah, I got it. Yeah. And then you could go here, you could set up your own custom desktop here, and you just say, hey Jarvis, activate Friday protocol. Supposed to do something. Activate Friday protocol. Yep. And you have song starts playing immediately. So these are some cool things, janky things that you can do. Yep. And the other interesting thing is Spaces VR automatically provides mobile compatibility. So you open this, it will connect to my iPhone, and you have a joystick here to move around, just like PUBG. So on iOS devices, it works best in vertical position. But for Android devices, you could also do it horizontal and use it like how you play PUBG, Call of Duty, all those things. And this is a hosted website, so you could go here and check it out yourself in your mobiles. You have this button, assemble, and these things. So I'll share the QR to the hosted website also. Now that was it. So let me just quickly go to the, yeah, this is the deployed version. So if you want to check it out, you can. I think this is mostly done by CPU itself. So yes. So yeah, I've tried to push its limits by if it's running locally on your device, so you can load how many ever models you want. Like this Iron Man model was around 200 MB, but when I tried to host it, it wasn't allowing me to, because Git only supports up to 100 MB, right? So I had to use Git LFS to host it, but LFS also didn't work. So I had to, compress the model a little bit. But if you're running it locally, it doesn't make an issue. Everything is done in the client side. So you will have some issues if you try to host it. But if you use some frameworks like Next.js for front-end, like a server-side rendering, then maybe you can overcome those throttling issues. This is only for VR, not AR. Only for yes. No mixed reality, only VR apps.
Are you seeing a shift in this kind of technology? Are people do they want to experience their websites or applications or whatever experience they have?
I mean, like it's not that common now here, but now that we have Apple's VR headset coming and all those, but not in India as of now, right? Maybe after this Meta, Oculus, and MetaQuest, they become more common. Then developers for virtual reality websites also demand will also increase, and will use it more often also. No, this was just okay. This was just a proof of concept. So my CTO asked me that if you could develop something for the mechanics, like the wiring harnesses and stuff, they have to assemble it, right? So to make them better understand like what's going on around the trucks and the cars. So that was, so I'll show you that also, the POC that I developed. Oh, okay, yeah, sure. So the real world applications, it's a cool thing to put on your resume. So that's real world application number one. And number two, you can show it off to your friends. That's real world application number two. So coming back to the real world application, training and simulations. So you could train employees in high risk industries like aviation, manufacturing, and simulate environments for learners. Bullshit. And this is what I was talking about, the newly released Mahindra BE60. So they have this very complex wiring harnesses. So what if the technicians can access this model, a 3D model of your car, and you just click on it and it becomes transparent. So you could see the wiring harness then. So and you could use it for architecture, engineering, that's it. So I'll quickly show you this thing. Yep, the POC. This was purely built on React 3 and this thing. So wait. Okay, it came now. So this was the model. So when you click on it, it explodes. So the technician can see what's going on inside the device and what components are there and everything. And when you click on this cursor and click on it, it becomes transparent. So we have this, and then navigator toolbar and this. So this is one of the real world applications that we developed for Volvo and Eicher as a proof of concept. So that's it. Thank you.
Hi. Yeah, that was pretty cool. I hope everybody thinks the same. Just so everybody knows, we have tea, coffee over there on the counter, for some fruits as well. If you want to help yourself, be my guest. And now we are continuing on to Ujjwal and Bala. They are from DevRev as well, and they will be talking about a really cool cutting edge feature that they are working on in browser analytics. I hope you find it as interesting as I do.
Hello. Yeah. Hi everyone. Welcome to the DevRev for today's React conference. My name is Ujjwal. I am working in DevRev as a member of technical staff. And the today's topic is that redefining in browser analytics using the DuckDB. Bala also would be presenting with me, and he is also a member of technical staff at DevRev. So let's go jump into the demo first. Cool. So yeah. So this is one of the sample dashboard we have here in the DevRev, and if you see that, basically it was really fast when you have basically clicked on that, and it opened in just a few milliseconds. And basically, even if I am basically changing the tab, it is somewhat instantaneous. Okay, and now if I am applying a filter of some customers, just check it out. So let's do some more examples. This is basically a ticket is somewhat what customer is filing here in the DevRev. Like DevRev the drill through. I do the pagination. I can do group bys here, and I am changing the group by. So, and the underlying process is that like whenever these things are happening, we are basically mutating one JSON structure which is creating a inherent SQL query inside, and we are basically running that SQL query inside the browser, and you are getting the analytics afterwards. So this is basically, you find it really cool, right? Like you will not be able to see this faster analytics if you are serving from the server. So now let's deep into the slides again. Okay, cool. Cool. So everyone is aware of the traditional analytics, or I can basically explain more in the details. So in the traditional analytics, what happens from the browser side, you have some structure or some JSON where you are defining that SQL query, and you are making a network call to your server. Server will understand that JSON structure, and like people are using mostly the ORMs like cube and all those things, and then those things are connected to your database, and like it reaches to your database, query get executed that, and you will get the response back. So, and what are all the issues you are facing on that? Yeah, latency is one, which is basically inherently slowness for the user, right? Yeah, API might fail. Also, there are basically, it is costly, if you are basically aware of that, like, and there are concurrency related issues as well. So first let's deep dive into how slow it is and why it is slow. And so basically like when you are basically having data on your server side, there is in between network related cost, and then you are executing there and sending back the response. So inherently we are seeing that even if you are serving from the CDN, the requests are around 200 milliseconds slow, and if you are going to the server, then it would be around 500 to 600 milliseconds slow, and it is happening for the each network call. And whenever you are changing the filter as well, or you are applying group by, or you are doing anything else, you are inherently there is a network cost that is accumulating. And now we are basically going to the cost factor. And so like we have researched that like if you have basically 4 small machines, then inherently you would be paying around $8K for 8 parallel queries that you want to execute for your clients, and this is basically monthly cost. So like inherently you would be paying around 100K per year to Snowflakes for 8 parallel query execution, and this workload might not be sufficient for them because all your users would be making queries to those 8 machines, and you would be getting response back from that. And if you are basically comparing the bill here, like more of those are compute cost, and if you are seeing the storage cost, it is much lesser. It is around 15 to 20% of the storage cost only, and everything else is just a compute cost. So like we basically run into this problem at the start only, and we are saying that like most of the customers are smaller or medium scale, and even if those are the enterprise customers, like most of their data just sits idle, and like many of the data would not be needed for the analytics, or you would be able to do some computation to make it smaller and then do analytics on top of that using summary jobs. So like we have redefined this problem on the DevRev, and for that like we have seen that like 99% of the queries just need the data more than less than 10 GBs, and 90% of the queries need the data less than 100 MBs. and this data you would be easily sent in a compressed manner to the browser, and you can run analytics on the browser itself. So, and like what are the benefits that we are getting, that like we are basically somewhat leveraging users machine for the compute and the storages that we are managing. And now you see that like our modern laptops are way compute specific. Like even if like I'm not just talking about specific Macs only, like your newer Windows computer also starts with the almost 8 GB of the RAM, and like new processors are really good. So like these are all the benefits that we will get if you are able to move the cost or compute to the user's machine. And you would be wondering that how we are doing it in the browser, right? What database we are using. So we are using DuckDB, and yes, go ahead. How do you load data? Yeah. So basically we have a BQ as a warehouse. From there we have a summary jobs, which is creating a smaller Parquet files and putting it in the S3, and we are getting those files from the S3 directly. Okay. What is DuckDB? So DuckDB is a free open source embedded in process relational OLAP DB. Like many of you wondering that what is in process. So in process would be that like all the DBMS related feature would be running then and there in the machine you have instantiated DuckDB. And how it is different from not in process DBs are that like you need to basically create the connection, and like DBMS would be like there on another server, and then you will basically talk through that using the connection and get the things done. And like in process would be generally much faster because you don't need to do that. And OLAP is basically a database which is specifically there for the analytics purposes, and how it is different is that it is organizing data in a columnar manner, and it is really suitable for the joins, group by, and aggregation that you wanted to do. And that's how it is different from the from your transactional DBs like somewhat NoSQL or other relational DBs as well. And now there is another question, that where you are running those things. Like if you are running actually on the main thread, then you would not get that kind of performance. So now like this DuckDB is running in the WebAssembly. So WebAssembly, or so called, you have heard the term of WASM, and like DuckDB itself gives a DuckDB WASM module, and in the DevRev we have written a really good layers to use it, and basically we will explain what all problems that we have faced when we started to build, and now at which point we have reached. That is upcoming in the talk, so stay tuned for that. And there is also another question that like you would not believe that like we haven't made any other API call after fetching the data that you have got. So like you get the data dump, like whatever tickets there, like 10,000 or 20,000, you will get all those tickets at first, and then there is no API calls, even if for generating the SQL as well. So we are generating those SQLs in the browser itself, and for that we have written one Meerkat TypeScript SDK, which is doing all those things for us. So like let me explain you what is Meerkat. And so like if you guys are aware about the cube structure, the cube is one of the ORM. Okay, let me explain somewhat in detail that a cube is a SQL, a JSON representation of SQL, where you would be able to define dimensions, measures, order by, filters, and all those things, and it will convert it to somewhat any SQL dialect. So we have written this library which takes the similar structure, so all the open source community can use this, and we will give you the DuckDB SQL back. And how we are doing it, like we are converting that cube like structure to the DuckDB AST, and DuckDB AST gives us those JSON serializer and deserializers that will take the DuckDB AST and give us the DuckDB SQL. And that's how we are doing it on the in-browser. And other than that, like this wrapper of Meerkat, like if you are trying to use it, it will give you more benefit of query execution handling, connections handling, how we are caching the files in IndexedDB or your user's memory itself. And we are seeing that how you would be able to swap the memory in between, because sometimes you will get the memory bump and you need to handle those things as well. And we will go into all those scenarios later in the talk. Okay. Now you would be wondering that, like, suppose that my data is giving you the 4 GB, how will you transfer that 4 GB to the browser itself, right? Like in the traditional JSON way or any those structures are not meant to basically transfer that much amount of data. So here, like, we are using the Parquet format. Parquet is also open source format, and you would be able to use anywhere, and you will get the compatible support in the DuckDB, because Parquet is also similar, that it is organizing all its data in the columnar way for the compressing and removing the deduplications. Now we will see that what all things we are getting in the Parquet. So like suppose that you have a like 4 GB of files, and like your data is not that much sparse, then you would be able to basically, when you are converting to Parquet, you will get 10 to 15x of compression. So you will get a 200 MB of file when you are compressing that, and that is basically, if you are dividing into 3 or 4 more, then you can send 50 MBs of 4 files parallelly to the user, and it will take just 6 to 7 seconds of download on the initial run. So like we are solving these problems in the bunch, that like this Parquet format helps us to send the data on the initial load faster as well, and how after the initial load, how we are handling that, you will get to know in the talk ahead. Okay. And other benefits we are getting is that like query processing speed, like Parquet is inherently columnar thing, so like DuckDB database is really fast with the Parquet format, and the efficiency that it is so much smaller than CSV and JSON. So now I'm inviting Bala to take through you on the next steps, that what are the challenges we are facing, what is the architecture on us, and how we have solved those challenges going up front.
Thank you, Joel. Can you guys hear me? Yeah. So till now we have seen why of in-browser analytics and what of in-browser analytics. So now let's see about how we are doing in DevRev. Yeah. So now let's consider this as a very high-level architecture, how we have implemented in-browser analytics. So we have two parts, client-side and server-side. So in the client, we have DuckDB. It is an in-memory database, and for executing the queries on top of that, so we need data sets. So the client side makes API call to the backend, and the backend gives the Serengeti files. So you guys must be wondering, from where are we getting the Parquet files, right? So we have stored all our DIM and factual data in BigQuery, so that is our data warehouse. We run summarize jobs periodically and convert it as a Parquet files and store it in the S3. So whenever the client side requests for a data set, so we pull out the S3 URL and give it to the client side, and client downloads it and write it in the IndexedDB. So one of the main reason we are using IndexedDB is because it is a persistent storage. So we need to don't need to download the Parquet files each and every time. So that is the reason for using IndexedDB. So now let us say we need to execute a query. So we'll pull out the data sets which have been stored in IndexedDB and register it in the DuckDB and execute the query on top of that. Is it clear for you guys? Yeah. So this is a very high-level architecture. So this is the client side is known as a DBM. So we have made it as open source in the Meerkat. You guys can check it out later. So this is the first DBM which we have implemented. So one of the reason when I mentioned first is because, so I think the life has been better. I mean, the life was good for some time. So, but after we onboard enterprises customers, we started facing some of the issues. Right. Okay. Cool. So now let's see what are the issues we were facing with the first DBM approach. First one is dashboard load time. So for example, first let me tell the challenge. Since we are using WASM, so WASM is a single threaded in nature. So we execute the queries sequentially, one by one. So because of that, for example, let us say we have a dashboard of 10 widgets, and each and every widget takes 200 milliseconds to execute the query, right? So it's almost 2 seconds of the dashboard load time. So we wanted to optimize further so that we'll reduce the dashboard load time. So few of the solutions which we explored here, right? First one is DuckDB COI using for multi-threading. So we tried to spin up multiple DuckDB service instances in the same main window itself, but that didn't provide desired improved results because it's still a single worker. So, but we started leveraging iframes through which we were able to spin up multiple iframes, and in each of the iframe we started a DuckDB instance. So through that we were able to attain the parallelism, so that we were able to drastically reduce our dashboard load time in overall. Yeah. So I'll just give a brief overview around the architecture, new architecture, DBM2, what we implemented. So the middle part is the main window, and we have a parallel DBM implemented here. So this parallel DBM takes care of creating number of iframes which are required for the particular dashboard, and also it takes care of sending the queries to be executed in the iframes. So let us say we get a query 1, and parallel DBM creates two iframes, and let us say we get a query 1 and we pass it to the iframe 1. So the iframe 1 make a window communication request to the parent window to get the data sets which are required. So the data sets have been stored in the index DB. So first we get a get request to the parent window. The parent window returns the files to the iframe. The iframe registers those files in the DuckDB and executes the query. And then the iframe returns those main query result to the main window. Then we render it in the dashboard. Yeah, this is a very high level architecture what we have implemented. Do you guys any have doubts here? Any questions? Yeah, sorry. So it depends upon the number of iframes can be depend upon the RAM size, so on. So because anyway, even with iframes, we'll have limit because we're going to use system resources, right? Depending upon the RAM size and processor, I think we decide what number of iframes has to be created, what number of parallelism we can do it. Anything? So we have an internal logic which creates a number of iframes. Yeah. Exactly. So we have the open source in the Meerkat DBM. Yeah, it is a separate package. We have open source data. Yeah. All right. Yeah. So this is few benchmarking results. So we have done on top of our dashboards. So I mean, I didn't mention our dashboard names, but I mentioned as dashboard 1, 2, 3. So these 3 dashboards have different metrics here. I mean, number of widgets and the data on top of which it's getting loaded. So 8, 160, 16, 200, so on, so right. So this first iframe you can consider as the first architecture DBM which we have implemented. So this is the dashboard load time for those. And the second iframe is the new architecture what we have done. So we are almost able to reduce our dashboard load time from around 30 to 40% from the previous implementation. Right. So the second issue what we have started facing, so the memory limitation. So as we started onboarding enterprise customers, the data size is going to be huge. So still the browser has limitations of memory rate. It is not infinite. So it has also still limitation. So WASM has a memory limit of max of 4 GB on which it can execute on work on. So there was some, because of that, so we can't operate on larger data sets and also multiple data sets which accumulate to maybe 4 GB of size, right? So we explored a couple of solutions here. First one was memory swapping. So in memory swapping, so we implemented LRU cache. So based on which we removed or deleted the data set which have been registered in DuckDB, which was lastly used. So we have implemented the LRU cache. Based on that, we free up the unused data sets and give it to the active queries for which the data set is required. That was the first optimization which we had done. And second was around DB shutdown. So DB shutdown in the sense, we generally shut down the DB after the database, the dashboard has been loaded. So after the dashboard has been loaded, so I think there is no need for the data still to reside on the memory, right? So we entirely shut down the database. So that it just free up the allocated memories for the data sets. Yeah, so this is around the second issue which we faced, and the optimizations what we are able to come up with. Any questions here? So restarting DB is around 200 milliseconds. Yeah. Any more questions? Yeah. All right. So here we are just explained around the future work, what we are thinking of doing. So if you remember, even we have a 4 GB of limit, right? So the WASM has a 4 GB of limit, and with enterprise customers, we might potentially go out of RAM again still, right? So few of the things what we are thinking to explore here is, first one is OPFS support. So that is our origin private file system, through which we'll be able to access the disk from the browser itself, so that we can do memory spilling. So that even if when we are executing the query, if it goes out of memory, we can spill the results to the disk and we can recompute it later. So that is the first OPFS support. Second is around desktop application itself. So moving our entire browser up to a desktop app. So one of the benefit what we get is, again, we get to directly access the file system itself or disk of the computer. Second thing is around the optimizations what we will be able to bring compared to WASM architecture and the native node. So if you compare DuckDB WASM and DuckDB node, the performance itself is better in terms of DuckDB node. So for the few of the queries what we have saw is almost 4x better in DuckDB node. So this is one of the optimizations or future work what we are planning to implement for our in-browser analytics in DevRev. Yeah, I think that's it from my side. Do you guys any doubt? Any questions?
You can basically ask any question.
Yeah.
Like if you are not able to understand something,
What measure are you taking to secure the data index? Because with this index DB,
Mm-hmm.
there was a client side.
Yeah.
no, like IndexedDB browser itself manages, and it is basically different for different hosts. So if you are basically registering under DevRev.ai slash something, then like no other host would be able to access that thing. Yeah, so no other host would be able to access that thing. So that is basically browser limitation that you get, and like you would be able to access the IndexedDB on your domain itself. Yeah.
That's a scripting attack, right? Like anybody can, if a hacker is able to install JavaScript on that domain, right? And if you go to that domain, it can execute that script and then take the index to be. So that's why like local storage is not preferred, because it's not that safe.
It's the same as making API calls to customer also. Like the data eventually will come to the user. What we are saying is that we'll prefetch the data. So regardless of how the API calls are made, how the data is fetched, it stays in the browser. The point being that eventually you'll get the data anyway.
Basically the difference is that what you are saying is that is the user's data, and even if you are using those traditional approaches, you are sending that data from the API, and it is there in your JavaScript memory itself, right? So like users, like they would be able to access the DOM. Like if they are able to access the IndexedDB, they have access to the DOM. So both are, from the security reasons, are the same only basically. And I'm not saying basically XSS attacks are for like indexing your database. Like IndexedDB is there only, and like it is the user's data, same as you are representing in the traditional way as well. Like the only difference is that we are fetching the dump in the start only, and in the traditional analytics you are making API calls on the every filter change or something like that and getting data periodically. Yeah. Yes.
Yeah, only read.
Yes. Currently it is only to read, but we are writing a query layer, which is basically like DuckDB is for just showing purposes, but we have a Mongo to update the SORs as well. So we are trying to merge both the experiences so people would be able to update as well, and like like DevRev query layer would be inherently would be able to understand that this data set has this SOR query, so make that query and update the same. Yes.
Yeah. Any more questions?
Cool.
Thank you, Ujjwal and Bala. That was insightful. Now, who doesn't want to save some money on Snowflake, right? Let's go. Give Meerkat a try. It might work for you, might not. If it doesn't, reach out. I am one of the maintainers, so I'll be happy to help. Yeah, I guess we have another presenter now, Shriram. Are they here? They will be talking about React query and how it can be used for data fetching. Yeah, let's see what they have in store for us. But just generally curious, can you raise a hand? Like, how many of you have been working for 3 years, 2 years? How many of you are in college? Let's start with 3 years. More than 3 years? First, let's do that. Oh, I see a lot of them. Cool. 3 years. 2. Cool. 1. Sure. 0. College guys. Cool. So just an information dump out there. So things like these aren't traditionally what front-end people work on. So yeah, really, this kind of sets the tone for what is coming in the future, in which people will be heavily invested in the compute on the client itself. So just want to point out that these are things to look out for. Like front-end.
I would like to disagree that because like you cannot estimate the client hardware, right?
That's true. Yes.
So that's the biggest problem now.
I think our hypothesis, at least at DevRev, the hypothesis is that the machines the users are using, they are pretty good and they are getting better over time. So say for example, you as a developer, so just one thing, when you are looking at a use case of say client-side analytics, you are essentially talking about data analysts. You can generally assume that they have good machines. And that is the running assumption that we are making. The idea is that going forward, say we are all developers here, right? We all have Macs, right? M1, M2. Most of us have Macs, right? Office Macs, right? So that is the kind of the prevailing understanding that going forward it's only going to get better. So going forward, you can naturally assume that things are going to come closer to the client, closer and closer, right? So when you think about front end, the only thing I am saying here is think beyond HTML, JavaScript, CSS. There is more to come and many miles to go. Cool. Shriram, everybody. I hope you have a good time.
Hello, check. Can everyone hear me? Yep. So before we start, if anyone can't see the code written here or the text written here, please scan this QR. These slides would be available as a website to you, so you can just follow along with those slides. So you can just scan this QR to get that slides to this talk. So once you're all done scanning, let me know, I can start. So all the text would be as big as at least the subheading here. So if you can see the subheading, you're good. But in case you want to scan and follow along, you can do that. Are we good? Can we start? Cool. So the last two talks that we had were, super cool libraries and ways of optimizing, your analytics and stuff. And the next one I'm going to be talking about is down to the basics again. How do we fetch data? And most importantly, how do we handle the fetch data, right? So this is the bare bones minimum that anyone needs to know as a front-end dev. And we'll be revisiting that and some good practices, bad practices, and some library that can help us do this better. Cool. So data fetching is pretty simple in JavaScript. You just use fetch, and in React you can put that fetch in a use effect, map that to a state. You can just use a use effect, right? Easy. What's the point of this talk? Well, let's look at it. So here I have a very basic fetch call where you have some data, you can fetch some data using the fetch API. If you have the data, you convert that into JSON and put it back into your state, right? This seems pretty simple, right? So anyone can use this. It's just 19 lines of code. Why do I need a library for this, and what's the point of this, right? So let me go back. So the first, there's one main bug here of doing this. Can anyone detect that bug? Page, right? So this is a this example here, for example, is when I fetch a set of products, for example, of an e-commerce store. I have to paginate the queries because I can't fetch everything. And if there are multiple pages and there's some crazy user who just clicks on the next button every 2 seconds, right? You can. But here's the main thing from the data handling perspective. What if my next upcoming page, sorry, what if my previous page takes longer to get the data than the next upcoming page, right? For example, page 2 will give me a result in 2 seconds, whereas page 1 took 5 seconds. Going by this logic, the fetch data of page 2 would have fetched before the page 1, right? Then when the page 1 data comes from the network, the data would have the page 1's results even though you are in page 2. This is a critical bug. A lot of us would have faced it. How many of you would have faced this bug? Show of hands. Cool, right? So the latest React documentation covers this, wherein you can use abort signals, yes, but there's a more simpler solution that is there in the documentation. So it's an extremely simple, elegant solution here. All you need to do is to have one flag that says whether you have to ignore the request or not. And then if at all a data fetch is already happening, you just don't write the results there. As simple as that. And how do I set the ignore to true? Each time this page changes, use effect runs again, right? At that time, when the use effect should return a function that sets the ignore to true. So what happens is this makes sure that only the current data gets set into the DB. Sorry, not into DB, into state, right? Again, simple. Why do I need React query or any other library for that matter? This works, you can use this, but this will not give you a good user experience. You need to have error states, you need to have loading states, and something that you need to also handle is how do you handle empty states, right? Let's add loading and error to this, right? I am still hell bent on using fetch and use effect, so I will go to any extent to add loading and error states. So I have added loading states. I have also added error states. Again, we have to use the ignore flag and then add this. Now this overall, in my opinion, gives you some sort of a foolproof way of data fetching. Like this works, right? But see how the number of lines has gone up just for this. So each fetch request takes around 32 lines here, and if you have a dashboard where you have to fetch multiple things, each of these could significantly increase your number of code. You could also say that I can export this into a common hook, which you can definitely do, which is not so bad, okay. But exporting that into a common hook plus more is what a library like React Query gives you, right? So this is an example of doing it on our own without any libraries. This is with React Query, right? So our 32 lines became 10 lines. All I have to do is have a key for each fetch and have a query function. The query function is the exact same as what we had for our fetch call. We just need to have a fetch API and then handle the response and error, and then that query function can be passed into our React Query's query function. 10 lines, that's it. It'll give you a loading state, it'll give you data, it'll give you error, it'll take care of, let's say, It will take care of all the empty states and all those things. So before we move into the next thing, I want to know how many of us have used use effect in a production scale application to fetch data. That is this code. No one? And how many of you have used React query in production code in your companies? Oh wow, I expected the hands to be the other way around. So yeah, that's it, just 10 lines of code and it will take care of everything for you, right? So here are some features of React query that you can use, and this talk is not intended for me to promote React query in any way. You can use any async data management library, you can use Redux toolkit query, you can use SWR, you can use anything, but the idea is to make sure our data fetching and more importantly state management is foolproof, right? So some important features here, you can read it out. Main 2-3 features are, first thing is caching, extremely important. It will save us on network calls and make our application much faster. Second most important, in my opinion this is the most important, it's query validation, query invalidation. It will tell you when to invalidate a set of query and refetch data. We will be looking at that in the demo. You can also refetch queries forcefully even if the cache has not expired. You can fetch data in the background. This along with some router libraries, you can fetch data before you go into the page when you hover just on the link, right? You can pagination and infinite scrolling. The first example we saw was an example of pagination. So that is inbuilt into React query by just specifying the page number as a key, right? It's extremely simple. Same goes with infinite scrolling. There's this new thing going on with optimistic updates, where you show the update on the UI and in the background update the thing on servers. Instagram does this very commonly with our likes, right? React query helps you do that very efficiently. You don't need to manage the optimistic states. You can do polling, you can do prefetching. Prefetching is what I mentioned with the routes. You can refetch on window focus. If you go to another tab and come back, you can fetch data again. And more importantly, you can also manage dependent queries. So if you have to fetch your user's details first and then fetch the dashboard for the user, you can call those two APIs one after the other, and React query will handle the dependency for it. If you have to do it manually, you have to check whether the state is there, then call it and so on, right? So dependent queries is also handled. So far, any questions? Nope. Pretty simple. Yeah. No, I haven't looked into it. Okay. Mm-hmm. So how do you think about kind of doing that mapping between the data that you got from issues, which may or may not have a sub unit of data from a different API that will already sit on a different cache? Right. A solution that you mentioned would be very elegant, or else we'll have to probably manage that state in the client, right? We'll have to manage that state in the client. We have to check whether that is there, then map through it and fetch all the details. So such complex things, if you don't have an elegant solution like how you mentioned, we'll have to run it on the server as a separate API. Yeah. Cool. So I have a couple of very quick demos here, just to showcase caching of React query. If you would like the other features, you can always just spin up a React query instance. There's a very good starter kit by them, or you can spin up any instance of your choice of fetching libraries. So here's a very simple code, right? I just have the code that I showed in the previous slide, where I just fetch data, set loading, set error, and then based on loading, I just show whether something is fetching or not. And this is a component that I have to show the data from an example API. And this button mounts that component into the DOM. Okay. So this is the component, this button mounts that demo1 component into the DOM. So let's mount it. So now I am fetching the data. I have on purpose loaded by 2 seconds so that we can see the fetching state. So yeah, I have all the data here. Okay. So now I'll unmount it again. And when I mount again, what do you think would happen? From cache? This is not React query. This is not React query. State? You mean it'll be in state again? Yeah, unmount and remount, it's again fetching, right? Because the state that this data is in a component that is getting unmounted, right? So it's refetching again. Let me just show that again. So it fetches every time, right? Yeah.
But does that not depend on the readiness of the response? Cache, value, validate. Implement, like if you are saving that data in your browser,
Mm-hmm.
then the next time you're making the API call, you're not actually using the API call, you're getting it from the browser. From the
Right.
cache. I mean, that's another implementation in detail, but that effect can kind of be achieved.
Right. So the basic understanding is that the fetch data function is being called again and again, right? So this is with the normal use effect. This is with your React query. So again, that the fetch accounts function is the same function that you saw in the previous slide, just that it's being passed into use query. All I'm doing is to set some cache time, stale time, and then whether to keep the previous data or not. Keeping previous data is something that you can use for pagination. Okay, and same thing. So I have a button here. It shows whether to fetch. If it's already fetched, there's an option to invalidate. I can show invalidate soon, and then show the data. Cool. So I'll mount this for the first time. Mounting for the first time, it's again fetching. Okay. Let me unmount this. Remounting again does not trigger this function, right? It doesn't trigger the fetch function again. It shows the exact same data. Now you might say that, look, if I do this and then there's a scenario where I have to add data, right? In that case, this data would become outdated, and if unmounting and mounting will not help me get the latest data, how do I manually have control over when to refetch this data, right? So that's where there are two options to do this. One thing is to refetch itself. The second thing is to do something called query invalidation. Okay. So refetch can be used if you want to fetch something on click of a button. For example, if you have a refresh button and you want to refetch the data, you can do that. Query invalidation is when you want to invalidate a certain query at a key, stating, look, if I add another page of data, or if I add another account, invalidate this page of data. You have that granular control over the set. So in our case, whenever I click on this button, there's something called invalidate queries, and I'm invalidating the accounts query. So this query is called accounts, and then I'm invalidating this so that the latest data is fetched again. So let me just invalidate. It's fetching again, and it's fetched. Since there's no new data, you can't see the new data, but I can assure you that it has fetched new data, right? So this is what happens. So assume that you had pagination to this. Then the query would be something like accounts and the page number as one more parameter to it, right? Then if I wanted to just invalidate the first page of that query, I can do that. If so only that first page, the 50 data or so, will be refetched again. So that's the main idea of this. This is a very bare bones basic example of how you would use some library like this. There's a lot more features that can be implemented on top of any of these libraries, which I think all of us should use and make our lives a bit easier, right? So that kind of concludes my talk. It was a small one. Any questions, queries? Yep. Not particularly. So you have more granular control while invalidating it. So for example, if you have a add function or using React query itself called mutations, on success you can specifically mention that you can invalidate this. Yeah, but you won't get granular control over refetching, right? Like for example, I can only invalidate, for example, if I have 4 keys combined together, I can invalidate just one of those combination of keys. So like if I have page number, then another filter, I can only invalidate just that one page and one filter. So you have that granular control of invalidating the query. And also one thing you have is you can invalidate this from any place, whereas refetch should be done something where, so for example, refetch is something that is returned from use query. Okay, so the scope of refetch would be inside wherever you are calling use query. Whereas for invalidation, all you need to do is to have this query client that is available across your app, and you just need to give the key. So you can call it from anywhere you want. No, instantaneously. Yeah, it would have fetched it. Yes, yes. No. Anything else? Cool, then you can scan, okay, hold on. You can just scan this QR to connect. There's the slides link, the GitHub for the slides, as well as my LinkedIn and my website. Let's connect and have a chat if any questions are there. Thank you so much.
Hi again. Right, so I just wanted to take a moment to call out that DevRev is in fact hiring. So if anybody, if anybody wants to maybe apply, talk about it, discuss the opportunities here, we would love to talk to you. You have some of the speakers. You have already met Shivam. I'll be somewhere here. You have Adit over there. Some guys at the back. We will be more than willing to talk about what is it that we do, what are the other cools that we're planning for some of the other React meetups, you never know. So yeah, feel free to reach out, and we have a break now. We'll give it 30 minutes. We hope that all of you would be back by say 4 or 5, something like that. Go out, get something to eat, feel free to connect, and yeah, let's do some more React, guys. Hello. Uh, we'll be starting in 5 minutes, so make sure everybody's back. We're starting, guys. Can everybody come back, please? Hello, 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 hello. Sorry? Thank you. चलो भाई बैठो. अरे नहीं तो. We're starting.
क्राउड को बस
क्या? बैठो नीचे बैठो. Look at what I have. Hello, hello, hello. We'll get started. Music.
hello.
Hi again. Yeah, we'll get started. We have 3 more talks to go. The next one is going to be held by Adit and Jatin. Again, both of us from DevRev. And yeah, they're going to be talking about micro frontends and how you can do injectable code in a really nice, type-safe, secure, performant way. Thank you.
Thank you. Hey everyone. I hope you had a good refresher break and got some time to catch up and relax. So let's begin the second half of our meetup. So myself Adit, I am a member of technical staff at DevRev, primarily working on the front-end side of the things. And let Jatin's mic.
Hello everyone, I am Jatin. I also work as member of technical staff at DevRev. So today we are going to speak about runtime micro frontends and how to build a dynamic marketplace around it. So before we start, I just want all of you to imagine like some small thing, like we are going to build a website creation app today in this next 30 minutes or this talk. And I want you to think along something like you might have seen Wix, Webflow, etc. But I want you to extend more and think something more ambitious, something more bigger, where website developers would come and they'll sell their React components. And there's other side of the spectrum where people will use those components to build their website. And we are talking about website builders selling their React components, developers selling their React components, and not their entire website. So let's see how we are going to do. So yeah, so on one side, like we have component creators who will be developing their components, plugins, etc. And they'll be listing in the marketplace. And on the other side, like as I've described, creators will be coming and building their websites on top of this. So how does it look like for the end user? So let's suppose I'm a user who come to this website and I want to build something. Then there could be different components like charts from a company called Database, a scheduling software or a booking system from Schedule Pro company. Then there could be payment components from Stripe, etc. And then there are obviously components from independent developers who want to publish this. So what are the challenges for this system which we need? So first challenge is like we don't know like which components the user has access to based on their let's say authentication system or their tier or whether they are free or paid user, the components can vary. Second, these components needs to work together seamlessly. Let's suppose I'm building a book something like book my show in the website builder, then I might need a booking software, and then I need a payment software, then third I might need a account details or user details component, and we need to ensure that all these things work together. Then there should be real-time updates between these different components, like change in one component should get reflected to the other component and vice versa. And all should be performant, like performance is again the key, because it shouldn't be slow or lag the system. Next slide. So you might be thinking like first approach is like the traditional dynamic import, where we just go, let's suppose we need a chart and we just dynamically import and it solves our problem. But there are two catches with this approach on why this doesn't work. The first is like for this to work, the components need to be defined at the build time. And here the people building components are not us, it's the third party developers, and we don't know which components they have. And second major concern is like they might want to run their own deployment, run their independent pipeline, and we don't know which URLs they are hosted at. So this approach is something which doesn't work for us. Now let's go to the second classic approach, or the very traditional approach, which is imports. We can just import these components as an iframe, where each component is a single iframe and it solves our problem pretty much, yes. But again, there are a couple of challenges with this approach, like first being, if I use two components and if both components use React, since I'm using iframes, it will fetch React independently in each of these websites, and this will lead to like memory issues, which further leads to performance degradation. Also, the experience with iframes is not so smooth because it's a website inside a website, and we need a native, much better and native experience. So again, the second approach, iframes eliminate for us. So now, like, how do we solve this? So we'll go to our, we'll just go back to, let's gather all our requirements once again, and then we'll see like how we can solve this. So first is like we need a load from anywhere. Basically, we need to load components which are hosted from any other website or any other company. Second, we need to load this on demand, like basically when a user logs in or only when they uses these components. Third, the resources should be shared. What do we mean by resources should be shared? If multiple components are using React or React Query or any library, those shouldn't be fetched multiple times. It should just be fetched a single time, and it should be shared between multiple apps within our website. Then performance again, and as we discussed earlier, then state sharing again, like how we discussed, like authentication and all those details should be shared between different components. And we need type safety for developers if they want to write their own custom components or add functionalities on top of that. So this summarizes our problem to two main things. One is we need flexibility to load from anywhere, load only when needed, etc. And performance in terms of like not fetching the same thing multiple times, etc. So this is where we need, and we are going to solve this via micro frontends. So let's understand what micro frontends are. Are we clear till here? Like, are you able to get along with it? Cool. So let's understand what is micro frontends. So micro frontends, in simple words, it's like a similar architecture like microservices, which is extended to front-end development. You can think of micro frontends as a website which has different apps within itself, and these apps are developed by different companies or even different teams or however they want, and they are all orchestrated into a single web UI. And we'll be using Module Federation, which is a Webpack plugin system, which will help us to do micro frontend. So I think we had enough of talk. Now let's try to understand this with a simple example. Adit will walk you through the code on how you can achieve this now. Yeah, over to you, Adit.
Everyone, yeah, so let's take this opportunity to understand how traditional micro frontend system works. I think it originated with a plugin in Webpack, but now the Module Federation ecosystem has evolved and it works with multiple bundlers. It's basically kind of now outside Webpack. So let's begin with the code. Just give me a second. I forgot to reset my branch. So let me quickly do that. I'll go and I'll go to the sources. and we discard and yep, and we'll get rid of the servers here. Okay. People at the back, can you see this font comfortably? Okay. So let's begin with what kind of setup do we have here. So we have a host app here. So in true nature of micro frontend, right? Like we saw that there is always a host app, a container app that you actually load. And then there are few remote apps. Like you imagine that there is a website that if you go to bookmyshow.com, it hits to an app which we call the container app, which takes care of the authentication and so and so. And then inside that we have few components which are like booking component, payment component, user profile component, so and so. And those are in itself are individual apps that exposes this component. So how that container or the host app can take those components which are in remote being served at different server or from different address, and how do we bring it into here, and how does module federation help here to achieve micro frontend. So as we can see, we have here, yeah, we need to zoom this. Is this comfortable? People at back? You are not in there. Okay, I'll zoom this one as well. Is cool? Okay. So we have the remote 1 app, remote 2 app, and then we have the host app. Oops. Okay. So what does remote 1 app has? Well, remote 1 app has a component called product recommendation. It is a component that fetches the products and renders which products are recommended. Remote 2, what does remote 2 have? It has product reviews. It has a component that fetches the product and renders the reviews of the products. And then ultimately we have host app. And all these three apps are Next.js apps. So we have, for the sake of the simplicity for the demo, we have taken certain assumptions. So we have assumed that all three are Next.js apps on the same version. Okay. So let's start by figuring out that how does this remote 1 app can really serve as a micro frontend app. How can it expose components as an API that host container can import? So for that, if we go to the next.config.js, we have a little plugin called module federation, Next.js module federation. And what it basically takes is certain configuration. So we'll go through each very quickly. Name. What is the name here? Name is nothing but the what do you want to, how does the host call this micro frontend app? So host will call it by name remote 1. It could be anything here. What is the file name? It is a path to generate the remote entry file. And we'll come back to it later what remote entry file exactly is and what is the purpose of it. It is the heart of this module federation. And then we have exposes. As it says that what do you want to expose from this app. So we are saying, okay, I want to expose product recommendation. Okay, I'll let cursor do its job. So it says that I want to expose something called product recommendation, which is at this place, components / product recommendation.tsx. So now if someone wants to use this product recommendation, they'll just do name remote app / product recommendations. And then internally how to, where this component is in that app and how to bring it here, that will be taken care by this remote entry file. But we'll come back to it later. Let's quickly do the same for the remote 2 app also, which is going to expose product reviews. Great. And it's a review. Okay. Everything clear so far? It was straightforward, right? And now we go to the host app. Now host app says that, okay, I don't expose anything, but I want to actually use those 2 remote apps inside me. How do I do that? So we have something called remotes. So you can configure remotes. That means what apps do you want to fetch your components or functions or hooks, basically your export object from. So we say, okay, already a little function written here. So we just call this function which returns the object. And it is a little bit specific to Next.js. If you are doing SSR, I mean, if it's getting rendered on server side versus on client side, the placement of remote entry file will be little bit different. It's either inside next static SSR remote entry or next static chunk and remote entry.js. Now, but we also want remote 2. Okay, so now let's understand. This remote one has to be exactly the same name as we gave in the name here. So this and this should match. The next part is nothing. The next part is nothing but the URL, from where it is being served, and the remaining is the path of remote entry.js file on that server, and same for both remote 1 and remote 2. Now let's understand what remote entry.js does. See, if we go into the index file, and we are assuming that the product recommendation will come from remote 1/product recommendation, as we discussed, how the remote one exposes it. But Webpack really doesn't know how to resolve this, because host app doesn't have a path like this. It knows it has a path like this. It has path next dynamic. It has /indexmodule.css. It has this, but it doesn't have this. So how does it resolve? And that's where the remote entry.js file come into the picture. Before resolving any of this path, this host app will first fetch the remote entry.js file from remote 1. And then remote entry.js file will have the logic of how to resolve these imports. So it kind of knows that there are certain special imports that host app cannot resolve in itself. It will go to the remote entry file of that remote 1 and tell us, can you resolve this import? It says, yes, I know what it means. And it fetches its own component. Does that make sense? We'll run the app and we'll see in the network tab what's going on. But clear so far? Okay. So now let's just quickly run all 3 apps. So we'll have remote 1. We want to remote 2. And before we run the host, let's really check that does this file really exist? Yes, it does. In next, static, chunks, and remote entry, if you do SSR, it exists, even for remote 2 app also. So that is the remote entry file. It has bunch of logic, right? Now let's run the host app, which is where we'll spend majority of our time. And it is localhost 4200. Great. So the app looks like this. Just quickly let's walk through the index. It does nothing. It fetches the products. It renders the products by its own here, and then it renders product recommendation and product reviews, and that's it. So we have these 5 products. We have product recommendation, and we have reviews. Now let's understand what goes when we reload the page again. So there are a bunch of JavaScript. Is this visible? The network tab? Okay, let's zoom a little bit. Yeah, better now? Okay. So we have this bunch of packages coming, but right at the bottom, we have the remote entry files loaded for both, which is, you can see here, localhost 3002 remote entry file, the same path that we gave. And after that, we load the components, product reviews, and product recommendation. So you can see product reviews come from localhost 3002 and somewhere. So this remote entry file knew how to fetch this component, because the rest of the modules, they are all coming from localhost 4200. The host app already knows how to load these JavaScript bundles. It was the remote bundles that didn't know how to load, so it fetches these 2 files. They're kind of like a manifest files which really knows like what to do stuff beyond this, and it fetches different components and just gives it to the host app. And for host app, I mean, it just works. So yeah, that's how traditional micro frontend setup that we saw, it works here. So if I want to add one more remote, I have to, let's say, add a remote 3 here, and then I have to rebuild it and then start it, and then it will know that, okay, we have remade 3 also. So that's what traditional micro front-end does. Now I will hand it over to Jatin, and he will explain that what are the shortcomings of traditional micro front-end and why it still won't solve the very problem that we were discussing from last 10 minutes, the dynamic website builder marketplace product. So yeah, over to you.
Yeah, thanks for explaining this, Adit. So we'll just discuss the problem, like what's the challenge with the code which just Adit shared and why it still doesn't solve our problem. So it solves most of the use cases, but something is still missing from what we initially discussed in our requirements. Basically, the components are unknown to the user till they log in into their website, because based on their access level, the number of components which they have access to or the components which they have to can change. And these components are developed by 3P systems, and the URLs, the config might keep changing. That's where the challenge is. Like when the user logs in, at that time we have to fetch the config, and then only we have to load the components based on the configuration. So the fetching config is the important step here, and we'll discuss like how we can achieve this. Now this leads us to an important concept like or a new concept in micro frontends, which is static federation or runtime federation. So what we just saw was like static federation, and by static federation we mean like the configs or the build files are defined while developing the code, like how Adit shared, like the location, like port 3001, it was defined inside our code, and then we were using that. But in runtime federation, it gives us this flexibility to change, to define the ports or the location from where the component is coming at the runtime. Does this make sense? Yeah. So again, with static federation, there is limited flexibility because we can't change when the code is built and shipped. We can't change their ports, etc. But in runtime, we don't do that, and we fetch it during runtime. So that gives us more flexibility. There might be a slight load performance issue in a runtime federation because there is some delay of loading the files because it's decided at the runtime. So we need to handle that carefully. And the scalability issues with static federation. While in runtime, it's more scalable because we can change things while they are actually running in the website. Now we'll discuss this more. Adit, can you go to the next slide? Yeah. So in static or the build time generation, in remotes, like how we saw in the code, the remote file one has like a static link and it cannot be changed. While in the dynamic or the runtime federation, the link is, we don't pass any remotes and it empty at the build time. And this is something we'll fetch at runtime. And Adit will show you more in code, like how we can do actually via runtime, this step.
Thank you, Jatin. So yeah, I think what we really want to solve is that we don't know what remotes are. We don't even know that from what remote, what component we want to load. And next.js.config, it doesn't really exist after you build it. Once you have the build and you serve it on the on a like, let's say you put it on Vercel, right? There is nothing called next.config.js that really exists there. So how do you, so you can modify it on the runtime. So how can it be like a API based behavior? So we'll try to mimic that. So yeah, let's jump into the code directly. First things first, we don't care about the remotes here because it has to be empty, right? And yeah, I mean, it's not getting used, but let's remove it anyway. So we don't have remote in host anymore. So, and I don't even know that these two components exist with this name. I don't even know what remote one is, and I don't even know that like from where I want to load it, right? So I can hard code in the code. This also goes away. Well, in that case, we need something like this kind of configuration that can be served from API. We can use this constant and build our entire solution. And we assume that, okay, if it comes from API, we can like just load it, straightforward. So we have the URL again from where it is being served. We have the scope, very important, because that's what it will expose. And then we have the module, which is actually the component, Little bit bad naming here, but yeah. So yeah, so let's just import it. And now we want to load this. How do we do that? Well, micro frontend, sorry, module federation. Module federation gives us the API for that as well. So if we see this remote wrapper, remote component wrapper, the module federation runtime actually gives us something called init and load remote, which are, now these things are completely agnostic of any bundler. They don't care if it's like Webpack or RSPack or anything, right? They are literally using it runtime into the into a JavaScript code. It tells us, give me the module, a module that consists of scope, module which is a component, and the URL. So it tells, give me this, and I will do two function calls. One is init, one is load remote. What init really does, it just fetches the remote entry file. The one that we saw, that even like in that traditional micro frontend, whether you import the component or not, the host step will always fetch those two remote entry files, because whenever it comes to the import statements, it can't resolve. It knows that these remote entry files can resolve this. So it's the same concept here. We just do it on runtime. So we fetch the remote entry.js file on demand, and when the remote entry file is here, we know what component to load. So module.scope slash module.module, it's nothing but literally remote 1 slash product recommendation. If we go into this configuration, it was here, right? Scope slash module, which is remote 1 slash product recommendation. That import statement stays the same. And so what we can do, we can actually use that remote component wrapper. We'll import it. So we fetch module 1 and we fetch module 2. We don't know what these remote configs are, we don't know what's inside that, but the runtime module federation takes care of it. So let's just, because we did change in the next.config.js, we will rebuild it, and we go here, and we close this for a now, and we refresh, and it works just the same way it used to. And if you see the network tab, okay, we'll ignore this. It didn't come before, but yeah, yeah, same thing. It loaded two files of remote entry, and it loaded then these two components, product recommended and product review. But some could say it doesn't feel like you're doing an on demand. So now let's actually do it on demand. So I have some code written here already. I'll do this, get rid of this, and I'll quickly explain what it does, and we pass it here. It's nothing but just a drop down of all the remotes. You select which remote you want, and at that time we will fetch that remote's remote entry file, and then we fetch the component, and then we load it. I mean, render it. So it's nothing funny. We'll go, we'll refresh. And here, because we have selected product recommendation, only one component has loaded. We search for remote entry, there is only one file from 3001. The remote 2 hasn't been fetched yet. Now if I clear my console and I load product review, now it will go and fetch the remote entry file for remote 2, and then it will load the component, the product reviews, and actually renders here. So now we can assume what kind of possibility it unlocks, that you can store the configuration, you can load as you need, and yeah, I mean, as Jatin talked about, right, that I mean, fetching those remote entry and then fetching the component, two sequential API calls could little bit take a performance problem. But there are ways that you can preload those remote entry files, like, and just not load the component, because remote entry files generally tend to be very lightweight JavaScript bundles opposed to the component itself. Okay, this looks good, it works, but there is one more problem that we haven't, yeah, I mean, I'll get back to it later. There is one more problem we haven't talked about, the state sharing thing, right? Because there are tons of components and things like authentication, so you need auth token to do API calls, you need users information. There are some very basic things that in a traditional front-end app, we fetch it on load and we keep it in a Redux or React query somewhere in stored in the state, and everybody reads it when required. How about here? You don't want these components to fetch all those basic configuration again and again. One way is to pass it through props, but right? It doesn't really. Who does that, right? So, I mean, there are classic problems of prop drillings and a lot of things. You don't even know that inside that component, how much it needs to pass even that, right? If you want to change something, it just, I mean, we all know that. Let's not go there. So, here we see that there is same product, API product get call, which is being called by the host application. And I mean, these are Next.js APIs, so let's not go there. But if you can see here, it is being called from the index.tsx, and again it's being called from product recommendation.tsx. But they are exactly same APIs. So as we saw in React query, right? Why can't I cache it? How can I take that that React query, that the query client object, the cache, and if I can just pass it out. Somehow our remote components can understand the context that host has provided, right? So, yeah, let's try to do that. So we'll go to remote one. We know it is product recommendation. It does classic fetch API, like it does a fetch API call and then set the state, data loading and error. I have some little bit code written here. So I'll go and get rid of this and we'll uncomment. Okay. What it does, it literally kind of assumes in the scope of this demo, it assumes this host app has fetched the products and we are using the somehow same query key. So it is kind of relying that I know you have fetched the products, I just want to read from your cache, right? And we'll do the same for remote 2 also. So we go to product, the product reviews, we get rid of this, copy paste. Again, same API, we'll just say that, okay, you can also read from the same cache. Okay, great. Now let's try to see if it works or not. Not this error, but we have another error, which says that no query client set. Use query client provider to set one. Well, you say, duh, provide the context. Well, we have provided the context here. And that's how host app is able to do the use query and fetch the API. But how do I really pass down the context from host to remote app? First of all, let's understand why it won't work. Why? Because when the remote app's JavaScript is bundled, although it has the 10-stack React query node module in it, it will be bundled separately for remote 1, for remote 2, and for host. And whenever remote 1 wants to use, that JavaScript code has it's a different instance of React query. It's not pointing to the same object. So when it goes and says, do I have a context field me? It says no. The object that you are referring, it's not been set yet. So that's how React context should work. So there is something that module federation gives here. It tells us that how do you share some of the modules between these micro front-end apps. Do we all got it clear that why it's not working right now? Okay, so how do we make it work? Again, there's something called shared. We did not touch here. But what shared actually does, it knows. So what actually does, it says that, yeah, I know like there are some modules that you want to share between your apps, and it makes it singleton. We'll come to it how it really translates to like in terms of JavaScript, right? So we just take this and we said, okay, you all should share this so that you all can actually understand it better. Okay? Now let's just try to run and see whether it works or not. I hope it works. Okay. Let's reload, and it works. And in network tab, if you go and see, there's only one product fetch call. Right? We loaded both the components, but only one time the product call went, and it went from index.tsx of host app. So how did it actually work? Well, how singleton works in module federation is that it really bundles those shared modules differently. So if we go in _next static and chunks, we'll see it is bundled separately here. It wasn't before. Same for remote 2. It also bundled this React query code separately. I mean, it's a separate bundle for it. And same for host also. And how it works that, let's say a host app loaded, it knows that there is a, I want 10 stack React query in singleton. So it checks, like, has it already been loaded before? If not, great. I will use my, I will fetch this bundle, and I'll run that code. Then remote 1 loaded. Remote 1 checks, has it already been fetched? It says yes, host has fetched it. Well, then I'm not going to fetch my own a bundle. I will use that. So essentially, all these 3 apps will point at the same same code, hence same instance. And this is how the context could work. It's little bit of anti-pattern in the favor of module federation. We say there should be no sharing and it should be completely separate. But it very differs from use case to use case. And if you really want to make a practical application, we have to take those calls. So I would say like this shared is a very, very good feature. Even if you see in the network tab, we haven't just shared the React query. It has automatically shared React DOM client, JSX runtime, Next.Head, and React query. So it knows that I know these 3 apps are Next.js apps, and so I don't need to, and I know that the React versions are same. I don't need to load this again and again. It doesn't make sense. So yeah, I think now it makes sense that if we want to achieve the problem statement that we started with, we can fetch the components from API. We don't need to know in front-end, in our UI code, that where it is coming from, what these components are, what the configurations are, and the state sharing could be a very common contract between like all this entire ecosystem. And yeah, I think that's pretty much sums up on the side of code that I wanted to explain. Are there any questions on this? We have few slides left. We'll just run through it. It's just the like yes.
Like in real world scenario, there can be cases where multiple apps are using different versions of React.
Yes.
So how do you think this will handle that?
So singleton is not the only thing that we have in shared. It also has something called eager import. Required version is the one that really helps us here. You can say that I want like only this version, or you can say I only want version 4. What it will do, let's say remote 1 says version 4, host says remote, like say version 4, but remote 3 has version 3. In that case, remote and host will share the same point to the same bundle that we fetched, but since remote 2 had different requirements, it will fetch its own. So this shared has a very deep lot of, I mean, you can see a lot of configuration even inside it. And shared can actually be set up in runtime also, how we set up remote and everything. But I mean, yeah, like it serves the same purpose. It's just like it was not the use case for this demo. Yes, yes. So the question is, can we have singleton while having different version? Singleton don't really say that only one and only one. Singleton says one given this other configuration. So given required version 4.5.0, I'll make sure that there is only one bundle loaded. Yeah, I mean, how module federation does internally would be another topic maybe next time, but that's how you can use this and achieve a lot of use cases. So yeah, I mean, all it says about how this you can use the init and load remote. They also have a preload and a lot of other APIs just in runtime, and it could really like solve whatever we want. And this is how the API might look like for the remote configuration that we want. And yeah, so we fetch the config, we initialize the remote by fetching the remote entry files. We loaded the components using load remote, and then we rendered it. And in network tab, we saw the same thing, the page load, and then we fed the configuration, then remote entry, then components. And then we touched a bit about state management, because we don't want the duplicate API calls, inconsistent state. It could lead to very poor user experience. You can't do optimistic updates if you want, and so on and so. So in state sharing, at least at data layer, I feel is bit important. And yeah, singleton, one instance shared everywhere. And there are a lot of other things in module federation. It inherently feels like you don't know the compound that you are, which is coming. Then how do I type safe it? How do I know that remote component is coming and what kind of prop it could use? Well, module federation also gives TypeScript APIs, which kind of at build time gets the TypeScript definition from the remote and put it in your app. It's not 100% perfect. I think there is active development going on. I mean, the maintainers and community working on it, but they're really want to make sure that like the type safety is not compromised. And yeah, we can do hot module reloads also, and I think the deployment patterns and testing strategy really changes with this. And yeah, feel free to go to the documentation. There are tons of examples how you can do with Angular and Vue and Next.js, React. What about different React versions and all those questions that we can think. They have example of every single thing. And yeah, this is the GitHub repository. It is a little bit much more than what we talked. And yeah, I would love to hear any. Oh, do you want to? Okay. So yeah, any questions we can take now? Yes.
So if I want to load a component on the server side, including all the data fetching and everything, to use Next.js, would that be possible? Because now I noticed that it was loaded, the data as well as the component JS files were loaded onto the browser.
It will do the same thing in server side. So you don't need to think how module federation will handle server side. You just write your code as you will be writing in Next.js for server side, and just treat this import as it will automatically be resolved, and everything will be taken care by the module federation itself.
Okay, so no extra configuration.
No extra configuration. The only configuration you need is to change the path of the remote entry.js file that we saw. Right, because we were reading it from chunks, but okay, where did the code go? It was, yeah, I think it was here. So here we changed it. If you are SSR, which you can figure out, this is like one of the ways to try to see whether the component loaded on client or server. But yeah, the only thing you need to take care of is the location of this file. That's it. Yes. Yeah. Okay, yeah. So the question is that how do we communicate back from remote to host? Between remotes. I mean, it's not a tree. You can think of it as a graph. See, if you want to talk between remotes, well, I just add in remote 2's remote that I also want to fetch from remote 1, and that's it. So, okay, I think it's remote 1 and HTTP local host 3001, and we have next static, and yeah, I think these chunks, I think we need to replace it with this, but yeah, so you can, then your micro frontend can become host for some other micro frontend app. It could also become a remote for other micro frontend app. Think of it literally as the microservice structure in backend. Once two services can communicate between each other, it just, you always need a gateway, like, right? Like, yeah, the connection between all the services, how do you initiate? So for client is a gateway, and then gateway talks to all the, like, there's APIs, then they talk to those the other microservices. It's the same concept here. I mean, there is one app, like if you want to go to www.youtube.com, there should be one app that is sitting at youtube.com. Other apps could be sitting anywhere. So we call it host because they are the one being called first. But rest, I think, like there are no, I mean, yeah, I mean, you can have exposes as well as remote, and it works. Yes. Sorry? Got it. I mean, treat of with the normal two components. Even if let's say, for the question is that we fetch the product reviews in host and product to renders. What if someone changed the review and now we also reflect it back to the host? That could be a good example, right? Or not? So recommendation wants to pass some flags back to the host app. Some kind of state between remotes. Remote 1 wants to pass on to remote 2. Well, props is always a way. Because they are just two different React components, right? So let's say there is a state in remote 1, right? And like remote 2 wants to modify that state of remote 1. For that, imagine even in normal React, the remote 1 will be importing a component of remote 2. So remote 1 can pass the data and, I mean, state and set state. And now remote 2 can manipulate that set state, right? I'm saying it is the same thing how you would do between two normal components in the same app. Like the React tree and the that structure doesn't really change here. You pass state, you pass set state, you could be pass it from prop and you could just manipulate back. It's like giving a on change or some kind of function. So just to quickly like understand, the product review could here also render product recommendations. It could pass some data which is in its own state. This is remote 2 state. It is rendering component from remote 1. It can also pass on change, and this component can change the data, I mean, depending on the function. So it doesn't really matter whether it's micro frontend or not. It's just how normal two React components could interact with each other. So you really don't need to think once you set up. That's what I'm trying to like come at with like module federation in the entire this a micro frontend this thing. I hope that answered the question. context won't work out of the box. So React query context didn't work out of the box. You have to give it. So let's say you are using some like a monorepo like NX. You are not limited to doing singleton of just node modules. You could share any of the, so I mean, let's just quickly open it, right? So it essentially, okay. It is essentially what we saw the example, they are in NX monorepo, where you have these libs here, which has like a lot of shared code between these multiple apps. You can take these libs and put it in singleton. So while those apps are being built, they'll make sure that not just node module, but even like any import that could be common, it could be into like singleton. You can make it singleton. So that's how you can make your context work, or anything like. It needs to point to the same JS bundle. Okay? Cool. Thank you.
Hi. Another fantastic project coming out of DevRev. But what I'm saying is, if the analytics piece did not scratch your brain, if this did not either, then we also had cursor subscriptions. So maybe that is something, who knows. Anyway, we have Veena presenting React concurrency. So yeah.
please. Yeah. Hey everyone, very good evening. Yeah, hope you guys are settled and sorry for the delay. Okay, so here most of you guys are tech savvies and you will be using the websites and you will be using a different kind of websites and applications although. So in this, how you feel if the application is not loading very soon? Have you, do you guys ever wish to visit that site again? No, right? Guys, I want you to be interactive. Okay. Yeah, but always the client needs a quick website, a beautiful website that will be kind of very responsive, etc. So when it comes to React, it is not just a library. When it was, initially when it was launched, until now there are a lot of, the major updates have come. And React concurrent mode is also one of that. Have you guys heard of it? Anyone? Have you worked with that? No? Okay. So today we're gonna see what React concurrent mode is and where all we can make use of it. Before that, like most of you guys not aware of what this is. So before that, when we say concurrent or a concurrency, it is like one or more tasks which get executed at the same time. So can anyone explain how React will render the UI? Right. So it is just like you will pass some props to the state and whenever the state gets updated, the UI will get rendered. In React concurrency, we can update multiple states parallelly. That's the main idea or the concept of this introducing the concurrent mode. And this is not fully fledged available, like we have the React hooks available for this. In the recent version of React 18, we are able to get these functionalities in the React itself. As a React hook itself, we can use these functionalities. Previously, it was just a standalone application which was there, like it was a standalone opt-in. If we required, we can just we can just add it and we would have used it. But in recent update, this is made available in the React package itself. So we can use it directly or we can use these hooks directly. Okay, what is this? The first thing is interruptible rendering. So whenever you reload or whenever you do some actions, whenever the state gets changes, usually the page will get stuck if you are rendering some huge components, correct? So this will make ease to render the UI at ease, and we can do the scheduling. So like in React concurrency mode, like we have option to prioritize what updates needs to be done when, and we can use suspense hook for fetching the data, which is kind of a huge data from the APIs, and we can use the use transition for low priority tasks. Okay, like this might be a little bit confusing for you guys, but basically these are the some of the core concepts which are available in core concurrent mode. So before that, like why does it really matter? What are the benefits of using this in the project? So it helps in improvising the responsiveness. When I say responsiveness, whenever the UI that appears, how fast it loads and how fast the actions that you take that will get updated, and based on the priorities we can just do that, and this ensure the smooth transitions. We know in the recent websites it is intended to add some animations and all, so how you can make those transitions smooth, and based on priority, how you can arrange the or how you can arrange the task basically in the project. So when you can use the React concurrency, does it require for small projects or does it require for big projects? Basically, what is the use case of this? This can be used for complex UI rendering purpose. Because this is a kind of extra code that you will be doing apart from the React, the code that we will be writing usually. So this is a kind of extra piece of thing that we are doing. This is not necessary for a simple applications. For a complex UIs, yes, it's. Okay. So I just want to show you guys a simple code, how this looks in action. Okay, when I say complex UIs, hope most of you are aware about stocks dashboard, right? So this can be a good example where in live the values will be getting updated and you guys will be searching for some kind of stocks and you will be adding it to the watch list. So this is one simple example. Guys, can you see the code? Is it visible or should I just increase the font a little bit? Is this okay? This is fine. Yeah. Okay. So, sorry. Okay, so here I have just taken one simple example. Just assume or imagine the scenario of the stock dashboards that you guys will be checking out. So there, first thing is the stocks will be updating live, stock price will be updating in live. And the other thing is the searching the stocks will be huge. It's not just tens or 20s, it will be like more. And if you guys are adding it to the watch list, so here is a functionality for that, a simple functionality that I have added. So if we want to do this specific, okay, this is a dummy one, the prices are not getting updated, just for the information. So here I want to demonstrate a couple of things. One is search, when you do the search, how you can make use of this concurrency thing over there, and while you add for the watch list, how you can manage these functionalities. Okay, hope I am clear. Yep. So coming to this stock list, so usually how you will implement this is quite straightforward. So we will get the data for maintaining the search, we have this search variable and the watch list and is loading or set is loading state for checking whether we are loading the list or not. Okay. If you want to filter the stocks, it is just like this is a straightforward simple example by you will be filtering through the stock names, like we will just lower the cases. So you will just check it through the list. So this is good for when it is just a few number of items in the list, but this will break if you use it for a complex applications. It is if it is more than 100 or a 200 kind of a list, this is not gonna be optimal solution. Okay, but usually this is how you're gonna do it in a simple application. And if you want to add to the watch list, so you will just add a set loading time, and in the set timeout, like just to mimic the real world scenario, I have just added the set timeout for that. So we're gonna add that watch list, that item to a watch list. Okay. So this is how usually a simple functionality will be added, right? You guys are clear so far how this is been implemented? Okay, with React concurrency mode, what we can do? So as I said, we can prioritize the task, and like in the same way, there are few tasks which are important, like high priority task, and which are low priority task. So here when you see, the highest priority task is rendering the stocks list, which will be updated in live. And what are the low priority tasks? It can be like searching the stocks and watch list, like adding it to the watch list, because like you can just wait for a second or two, if you add for the watch list, and even if you search, you can just wait for a fraction of seconds. That doesn't make any lot of difference. But when it comes to stock prices, it is very critical over here. we can't take a chance over there, correct? So in this case, here couple of functionality, as I told, like it is just not that high priority task. So what I have done is I have added it as a deferred search. So this is one of the hook which is available in React concurrency mode. So in deferred search, what it does, if there are any other tasks which are running, so this will be a kind of next task that will be taken care of. And when it comes to adding to set watch list, so we use start transition using like use transition hook. Okay, so these are these are the hook guys, functional, like these are the React hooks. So like if you want to set them as a low priority task, so you can just use them. Okay, let me demonstrate how this actually looks in the UI, so that you guys will understand much better rather than what I say. So in this first example, this is without React concurrency. Like if I click on watch, you guys can see some fluctuation happening in the screen, correct? Fluctuation happening in the screen. With React concurrency, how does this looks? You guys can see it is, the UI is not getting fluctuated, and the the tasks are getting completed, but it is not varying the UI what you are seeing. The UI is kind of very constant, and the tasks are like watch list is getting updated. The rest of the UI is same. And when it comes to search, I don't think so. In this example, you guys see much difference, since the list is very less. But when it comes to the major functionalities in the application, that makes a very big difference. Okay, so far we came to know, like, okay, in React concurrency mode, we are able to prioritize the things, and we can update the UI in a different segments without affecting the other. And in this, like, okay, we can use it, but there are some drawbacks. The first thing is the compatibility. We don't have compatibility and the migration issues. The thing is, the older legacy version of the React doesn't support React concurrency mode, and whenever you want to add it to the latest application, some code changes are required for that. And more than the code changes, the developer should know which task should be deferred and which task should be prioritized. So that kind of information is much critical. Like instead of implementation, like before that, we should know what exactly what functionalities to be used where. So those things are very critical over here. Yep. So basically, when it comes to current concurrency mode, it is very good for developing the responsive websites or performant websites. I think by this I would like to conclude my short talk. If you guys have any questions. Yeah.
I didn't really understand why the UI was going into the loading state when you were clicking the watch button. When you didn't use the React concurrency. So can you go over that bit once more?
1 second. Let me rephrase the question you were asking. Like in without
without concurrency, whenever you click the watch button, the UI was going in the loading state. This exact
yes, yes.
So why was that happening?
Okay, so basically in the dashboard.js, like I have added the set timeout for that, because in real time, why like you might have that little bit of lag.
Not exactly sure, like why, what lag?
Like whenever say you are adding to the watch list, so you are sending the data to the API, and you're just getting the response and you're just updating it. And like of course like you can just have some kind of delay in that, fraction of second delay. And like while you're doing that in without concurrency mode, what happens, at a time you can just do that specific task alone. Meanwhile, if something is getting rendered, yeah, because there are three things, two things we have to check over here. One is the priority task is updating the price in real time, which will be happening in the background. And when you click on watch list, so this is a kind of a new state that will be getting hit, right? So here the advantage of this is, even though you are getting the live updates, you can also have the task of adding it to the wish list, I mean watch list.
So just one more thing in the dashboard RCM code, I believe there is no set time. If you add that piece of code,
That is a purposefully that has been added in the other code.
but there will be lags in the RCM as well, right? If you replicate the same exact code.
Yeah, it's a good question, it's a good point actually. Of course there will be a delay, that is why we have added it as a, you can just see, it is added as a transition, because this is a lower important task compared to the priority task.
But in transition, if you add a set time mode, it won't go in the loading state.
You mean for the RCM?
Yeah.
It does, since it is like we are doing it manually, it takes a.
I believe the question here is that it's a little hard to understand what exactly are you achieving with these stages, because in one of the examples the problem was that loading state which was artificially induced to demonstrate a point.
Yeah.
But in the other example, which was supposed to be with a better version of the old code, the issue that was causing the loading screen to happen, that piece of code is not there. So it's a bit hard to compare what exactly is the change.
Okay, so let me just explain one portion of a code. So usually rendering happens when the state gets changed, right? So here what happens in the React concurrency mode, you have the flexibility to prioritize like what task needs to be done at what instance, and you have the capability to stop the task, interrupt the flow actually. When I say interrupt the flow, so in this example, the live stocks which are getting updated, right? Okay, this is just a, the simple example that I have taken. It's not necessary,
Let's say we have received the response from prices API and
Yeah.
watch API at the same time.
Yes.
It will prioritize the prices API over
Yes.
that because we have set it as a higher priority.
Exactly. Yeah.
Thank you.
Yeah. Any more question, guys? Yeah, okay. Thank you so much.
Yeah, fine. Final presentation of the day, guys. We have Adad. He is going to be talking about WebRTC's 101. Yeah, take it away. I have no jokes.
He wants to charge. Where can he charge? Just 10 to 15.
No worries, no worries.
it's appeared, but it's only showing the extended screen, not the display. I'm getting the duplicate screen. Okay, I'm not getting the duplicate screen.
Or not recording, you can come to the table.
Connect my laptop. You can use StreamYard to present from your computer, but I will connect my laptop. I'll make it work. You can disconnect yours. You can connect my laptop and you can come back to your recording setup. Can I sent you a StreamYard link. Just give us a minute.
You have to duplicate your screen.
How to do it?
Displace it.
I'm audible. Hello. Hello everyone. Am I audible? Okay, voice is all clear. So we had some technical difficulties because it was, I think, MacBook assist. I have a ThinkPad, that's why. MacBooks आपके पास नहीं होता Lakshman, so. Anyways, very good evening everybody. My name is Vad Parker and today I am here to give a talk on WebRTC 101. You know, a deep dive into how real-time web communication works. So my first question, how many of you here know what is WebRTC? Okay, now that's fine. Now how many of you know, like, have you heard the term that WebRTC? It's something that is, you know, Zoom uses, Google Meet uses, but you actually don't know how it works. Have you heard the term WebRTC? Okay, nice. So don't worry, today you will learn what is WebRTC and you will walk out actually knowing how WebRTC works, right? How I am so sure, because I know I'm here. And how good you will learn it? You will learn it enough to write it in your resume. All right, let's start then. For first thing, like, what is WebRTC? So WebRTC is like the core protocol where you can do a real-time media communication. So that's the only protocol. So we know that WebSockets, right? WebSockets is used to real-time messaging communication. If you want to send a message from one browser to another, you have to use WebSockets. But if you want to send media, you cannot use it via WebSocket. You have to use it like via WebRTC. You know? And see, WebRTC is going to look a lot of complex to you because it has a lot of jargons, very scary jargons, right? And today I'm here to I'll break it down to you. We'll go step by step, all right? And finally, you'll be able to understand what's WebRTC. So first jargon is P2P architecture. Anybody knows like what is P2P? Peer-to-peer? You mean this? Right. So not this peer-to-peer, but peer-to-peer architecture basically means that your browser, your device is considered as a peer. So when we say peer-to-peer, right, you send media directly from one browser to another browser. So media is directly sent. There is no server involved. There is no server cost, no nothing. You are sending it directly from this device to another device. And that, in my opinion, is like the single greatest selling point of WebRTC, right? And now we are going to understand like how it works. Well, you see, 2025 is approaching and front-end developers cannot escape servers. So it's very naive to think even WebRTC will not require server. WebRTC does require server not to actually communicate the media, but to actually know or sharing how the IP addresses. So signaling server is just a normal server which is used to share what is the IP address of browser 1 to browser 2 and what is the IP address of browser 2 to browser 1. Unless you don't know like IP address, how are you going to send the media to the device, right? That's how it works. And it's just a signaling server is like a fancy name. It's just a normal Node.js server. And basically, usually it's a WebSocket server because you want, you know, real-time connection. You can use HTTP because, you know, why not? And then stun server, right? So session traversal utilities for NAT. What an amazing abbreviation, right? It has a abbreviation inside its own full form. They could have just told it as, you know, stun-at instead of stun just. So I'll tell you what stun is, right? What if I tell you like this device, right? This device does not know its IP address. It knows its local IP address, but suppose you're connected to a cafe Wi-Fi, you know, your favorite third wave coffee. The MacBook wants to go to Starbucks. You go over there, you connect to its Wi-Fi, right? It has a public IP address. It won't be able to know what's its public IP address. That's why we have a stun server, right? So the browser sends a request to the stun server, and the stun server returns back the public IP address. And based on the public IP address, you're able to send it to the browser too, and WebRTC can take place. So there's also something, right? It will stun server allows the device to discover its public IP address and port assigned by NAT. Fine. Another jargon, NAT, which is network address translation, which basically, this is a very simple one. It translates the network, okay? So what NAT does is, right, imagine you're in a hotel and you log on to the hotel Wi-Fi, okay? So each room, right, each room will be connected to the router, and the router has a public IP address. See, you are only there on the hotel for temporarily. If you create a unique IP address for each and every device, right, it's going to be a lot of load, and it's going to be useless because it's a temporary IP address. So the router assigns a port, and each room number will have a different port, 1001, 1002, and it has a one public IP address. So any request which come to this public IP address, the NAT will decode it as to what original hotel room number or original port IP address it went to, and it will route those requests to over there. So that is what NAT is. Now, if you get the public IP address, right, your public IP address will be this. But for WebRTC needs to know, like, what is this? The hotel room IP address, because the device will send media directly to this. That's why you need a stun server to know that what is your IP address port behind a NAT, behind a router. Okay? All clear? Right. Interactivity, connectivity, establishment. Right? Another very scary jargon. ICE candidates. So what are ICE candidates? ICE candidates are nothing but all the possible endpoints, all the possible IP addresses through which you can establish a connection. The devices can establish a connection and send media to each other, right? And especially ICE candidates is like, okay, you see the diagram over there, right? First is a browser. It has a local IP address. Your device has a local IP address. Second thing, you will have a NAT. Like if you are behind a hotel Wi-Fi, public Wi-Fi, what is the port number assigned to you via the NAT? And then third thing is turn server. So I'll explain you turn server. But see, browser is local address, NAT is server reflex address, more jargons. They like to make everything sound cool. Then last is turn server. So what is turn server basically, right? The problem is that now if you go over here, right, in the router, right, the router will make a connection with the stun server to know that what is the public IP address and the port. But if it directly receives media from the device, right, from the other device, it has never made connection to that device. So some NATs are very strict that if I have never made connection to you, there is no TCP connection ever, then why should I receive any response from you? So it blocks it. And it blocks media, okay, it blocks media actually. So for that, right, we have the turn server, traversal using relays around NAT. Okay. And just nothing it does. What it does is that the browser one sends media to the turn server, and it acts like a proxy server which sends back those media to the browser too. All right, that's all it does. It acts as a proxy server. So that the strict NATs, right, not all NATs, but very strict NATs who expect, to only get data from the IP address which has made connection to, will not block your media. Next we have session description protocol, STP, right? Tired of so many jargons? Yeah. Even the JavaScript world is tired of so many frameworks. Yeah. So SDP is like, it's a single file which contains all your ICE candidates, and it contains the media you want to send, what protocols you have used to encode the media, like you can use the UDP or the TCP. So this is like an example of the STP file, right? Not something that you have to buy it, but let's see if you are a WebRTC engineer and you don't know what's working, what's not working, right? This is the file that you have to come to debug, right? It's their version of why the div is not centering. So you can see that right now this SDP is all about audio. It will send back the audio, and it has all the ICE candidates. ICE candidate, the local ICE candidate, the ICE candidate behind the NAT, and the ICE candidate from the turn server. So it checks all the ICE candidates and see that which ICE candidate would help to make a connection. So as soon as it gets a connection, it sends the next part. Next part is the offer and the answer. Offer and answer, okay? Yeah, this one is like a simple jargon. I think you will understand it. Yeah. Right, not this offer answer, but offer is basically a concept where, you know, if this device needs to send media to another device, it has to make an offer. It will consist of an STB message. So it will have its own ICE candidate, it will have its own media, which it will send. And then the receiving device will send an answer, which is own SDP, which will contain all ICE candidate and send it. So it sends an SDP message, that is an offer, and this device will send an answer, which is also an SDP message to establish a connection successfully, right? Now we go to implementation, all right? So implementation, we'll go step by step, okay? Step 1, you have to set up a signaling server. A signaling server is nothing but a WebSocket server. So can you see this? Yep. Okay. So over here, right, WebSockets, right? So nothing yet. You have to create a WebSocket object, and you have to create a sender socket and a receiver socket, because those are different objects, because those are going to be like different clients. And then there are different message types. For example, is the message type is sender, right? And at time you have to set the sender socket. If it's a receiver, you have to send the receiver socket. That's a basic web socket. And then we have like the create offer. Like this create offer can only be, come from the sender socket. If the event is not by the sender socket, we have to cancel it. And so when the create offer comes, right, you have to send the SDP message, the SDP file to the receiver socket, which will immediately get via the web socket. Similarly, for create answer, whenever the receiver socket gets the SDP, it sends it to the sender. And lastly, we have ICE candidates, where you have to share each other your ICE candidates. So this is the gist of it. Now step 2 is that we have to set up the sender's RTC peer connection. So RTC peer connection is basically an object. Okay, it's a native to your all browsers, right? How we have fetch, right? We have RTC peer connection as well. So nothing that you have to just set up, const pc is equal to new RTC peer connection. This will handle your everything. This will generate an offer for you, generate an answer for you, and take care of your STP, take care of your media and everything. This is done by the RTC peer connection. And this is a walkthrough of the code where as soon as the component mounts, we are making a WebSocket connection. I have used use effect because I didn't know that people are today eager to learn React query. I mean, this was the OG one. Don't forget the gold. All right, so just basic connection over here. Next, we'll go to the step 3 is that the sender creates an offer. Now the sender has to create an offer. An offer is nothing but an STP message. So we have something called as a callback function. On negotiation needed. So on negotiation is basically when sometimes if you create an offer before a connection has established or before you are able to get all the ICE candidates, it will time out and it will give you an error. By the callback of on negotiation needed, it will only send the STP when a connection has been established, when the negotiation has been done. So that's a callback over there. And this is the on ICE candidate, share your ICE candidates on negotiation. And lastly, we have the get camera stream function. This function is nothing but you get the media device. So you can choose whether to get your display media or share your screen, and then finally you stream it pc.addTrack, object.addTrack. addTrack is also a callback function method where it helps you to add your media to the send the media via the WebRTC connection. Next up is that step 4, we have that receiver sets remote description and creates an answer. So first of all, before I go, right, there is something called as local description. So local description means that this is the STP local that you have to set, and remote means that it's the STP of the device that you want to send the media to. We have to set up for this device as well and this device as well. So obviously, so for the receiver, right, the receiver's local description is its own, and remote description is this SDP, the offer which is given, right? Might sound a little confusing, but you just have to remember that it's all about where do you store the STP. The SDP of this device will be stored as a remote description in that device. The SDP of that device is stored as a remote description in this device. That's all it is, and that's how the WebRTC connection is established. And all a bunch of code over here. And then lastly, I'll repeat again that whenever there's a create answer, the sender socket, we send the SDP, the answer SDP to the sender socket so that it's able to complete the connection, right? Sender sets remotes and media, and same thing, like when the sender gets back the answer, right, it has to set the local description, and whenever there is an answer, it sets a remote distribution or either adds the highest candidate. Bunch of code, yes, but that's the basic logic. And now we'll go demo. All right, let's see if it works. All right, so I'll tell you one thing, okay? One problem with is a browser problem, that if you send a video over there, right? For the demo purpose, I have kept 2 tabs, but if you send the video over there, right? Unless you are active on this tab, it will not accept any videos, right? So as soon as I click, so I'll refresh over here, and after I refresh, right, it should take some time. Yes, it's there. Okay, good, it worked. So this is the WebRTC connection. We are able to send it without any server. So that's all. And I think let's see. Okay, smile everybody. Right, print screen. Okay, I don't know where print screen is. Okay, F print screen. That's okay. Okay, done. Thank you. That was good. So lastly, I need to share another thing. I'm not here to just take a selfie. I have to like tell you another thing else. The problem with P2P, right? P2P architecture has a problem, right? The problem is that anytime you want to share your media to multiple browsers, you need to do the same, create offer, create answer, set remote, set local to each of them. So all 4 of them. You have to maintain all 4 socket connection, all 4 SDP and everything, and you need to send the media to all, all 3 of them. So because of that, right, your Wi-Fi bandwidth, it will not scale up because it cannot handle sending media to 3 or 4 different devices at the same time, right? And especially, using a public Wi-Fi, it just cannot do that. And that's why the solution for this is, right, SFU architecture, selectively forwarding unit. This architecture is what is being used by Google Meet, Zoom. They don't use WebRTC, they use this. The reason is because, browser 1, browser 2, browser 4, all of them send their media to this server. It's like a proxy server, and it has a huge bandwidth, like 10 GB per second bandwidth. It's a huge bandwidth, and its only task is to just forward the media packets. That's all it does. So it gets some media from browser 1, it emits all to the browser 2, 3, and 4. All browsers receive and send it. So there is a problem with SFU as well because it's very heavy on the client. Because if you get 3 media, media response data from the server, right, you have to handle the connection and you have to display 3. So like if you have been in like multiple calls, right, 10 or 15 calls, right, you need to like quickly your client might start hanging up. And because of that, right, we have the MCU architecture, multiple conferencing unit. So what this does is that, if you get a lot of media, right, let's say media, audio and video, right, you get like 100 media and audio. You are on a Zoom meeting with 100 people, maybe your COVID graduation day, and then it gets decoded. It has to first decode audio and video, then it merges it, and then finally it encodes and sends the final media stream. Right, so it's very expensive actually because it has to decode it, very expensive, but it's actually a use case that you have to decide because it's very easy on client because all your clients, even all 100 of your clients will have to only process this final media stream. Instead in the SFU architecture where they had to process all 100, all 100 media streams. Just a question of whether your front-end team is better or your back-end team. All right, any questions anybody? And this is my QR code, I'm only active on Twitter, right? Yes. The client is not decompressing, the server which we are using, that is decompressing actually. So that is encoding, decoding and then sending the final media stream.
The client only knows one stream and it knows that how to display with multiple.
Yeah. So basically like suppose that there are like 4 people is video turned on your call, then how does this encoding, decoding will work? Like all the 4 videos will get encoded as a one stream.
So I think in Discord, right, if you have 100 people join in Discord, there is something called as audio crackling, and it just become a nightmare where you are playing 100 audios, and you can merge all those audios. So you want like differentiate, or you don't care whether the audios are merged or they are coming separately,
And when it comes separately, right, it's very easy for the client to process it because it's just one media stream. So that's what MCU is used for. So you have like 100 students in the tab at once, right? Then it merges all those audios and video and shows it as like one. Yep, that's it.
This can work because like you can take audio from multiple sources and give one output, but for video it might not because you need to display different videos, right?
So that's a very, that's a smart way you can do that. You can send a one media stream, like one media stream, and then have a CSS kind of thing. You put a overlay of borders over it so that it feels like you are like watching 10 different videos, but no, it's just like a one single big video which CSS magic happens. Yeah. So P2P, yeah.
So does this encoding and merging happen for every client separately? For example, if I have someone on mute or I've hidden their video, so and the other client is seeing all 4 videos, so the encoding and merging will happen separately for both.
So I think when you hide someone's video, right? So in the MCU architecture, you still have a server, right? So let's say one thing I forgot to mention in the P2P architecture. Let's say you change the quality of the media, right? Quality of the video. In P2P, it's very difficult. You have to first cut the connection and make a new connection of 720p and then restart the process. In SFU, like whenever there's a server involved, right, it can easily do that. It can stop sending the media and it can just translate it. In the MCU as well, if you have a different requirement, right, and if you block a media, right, then it can detect that and then send you the final output. Okay, that's all. Sure, yeah.
Yes. So my question was regarding like what kind of library, first of all, how is it socket.io different from WebRTC, and does socket.io in underlying use WebRTC?
So socket.io is like a library which makes the WebSocket connection like simpler, and it's only used, it uses a server back in the behind, and you need to send the messages from this to that in the real time, only text messages. So that's when you use WebSocket. But you cannot send the the media via the WebSocket because it's very costly. That's why the WebRTC was a philosophy that you can send media directly from this client to client, so there will be no cost or there will be no performance issues on the client. And WebSocket does not use WebRTC in the. There are two different protocols actually.
Okay. And another thing that I wanted to add is when I started WebRTC, I think just wanted to mention this resource that they have a very good website for resources itself, and it helps you because WebRTC grows upon it. You cannot know what are the native APIs which are there with WebRTC. So if someone like really wants to start, I feel that would be a really good place for them to understand WebRTC and then like understand how can you even stream your resolutions, because that is a problem statement that you will come across when you start using WebRTC. You also mentioned that there is a bandwidth problem also that occurs. So yeah, just wanted to mention that.
Yeah. So what I showed was like actually the core thing. There are few libraries which help the dev experience, like they are the React query of WebRTC, for example, Media Soup and all such. So you can just search about it, Google. It's a very interesting thing and very simple. All right. Okay. So end of the talk, and actually I end my talks with a joke. So the joke of the day is that what is the name of the musical instrument which is absolutely hated by backend developers? An accordion. Okay, thank you so much, guys.
Satoru Gozu.
Not going to.
No, he's Gozu Satoru.
Hello. Just keep on saying next. Okay. Hello everyone, can you hear me? Okay. So I don't need the mic, I guess. So my name is Nitin.
You need mic because YouTube.
Okay. Hello. So my name is Nimit Sawant. I recently joined DevRev as a developer evangelist, and my main work here is to push all the community initiatives. We have been doing a lot of groundwork with agentic AI, and we have been building our own agent OS, and we thought to advocate about agentic AI to like just in general out there. We have written a lot of articles also about agentic AI, and we wanted to create a community around that. So I thought this would be a great opportunity for us to share about those community initiatives. Just the aim here is to just create a community around agentic AI, and to also grow the community of folks who would like to contribute to our open source community. We are building a very big community of snap-ins, which will help for you to build upon our agent OS that we are building right now with DevRev. This would be a completely open source initiative for you to contribute and work with us. So we are also in planning of developing a champions program overall India at the moment, and we're just pioneering that, and we have created a small Discord server where we're just starting this small initiative. We have some partners also which would be joining us, who would also be contributing through their companies, through their efforts into agentic AI, and so do you want to explain more about snap-ins?
Yeah, sure. Hello everyone. So I'm sure you must know a little bit about what DevRev is. Now we do have a good platform which exists over build, support, and grow another applications. But if you want to customize that, if you want to add your own automations and flair and UI things on top of that, there is something known as snap-ins, which are basically small apps which allow you to extend the DevRev's capabilities. Okay, so so these snap-ins, they can be any kind of automations, they can be integrations with some third-party applications like, can you go to the page? Yeah, sure. Yeah, so they can be some integrations to some third-party applications, integrations with some internal DevRev applications and automations. So for example, we have these kind of existing snap-ins. Most of these were built in-house, but some of them were built by partners and developers. So like for example, we have integrations with Slack, WhatsApp, Gmail, etc. So basically, there are certain documentation and guidelines which are provided over here. So can you go to the developer page? So if you go to this docs.devrev.ai and the developer section, we do have extensive documentation on how you can build these snap-ins. Right now, the way to write the custom code for these snap-ins are in TypeScript. But yeah, that's the overall thing. So there are a lot of code words and jargon over here. I won't go into each detail, but yeah, this has a lot of information about how you can build your own snap-ins and how you can contribute towards enhancing the DevRev experience.
Thank you so much. I think now the last question is how to go back. Wait a second. I'm sorry. It's arc sometimes now. Can you see where my... Okay. So the question is that how can you contribute to this community? Can you just go back to our slides? Control tab. Right. Yes. You can scan this QR. We are just in the process of creating this Discord community, and right now we are starting out a program, as I mentioned, the Champions program, which will help you to contribute back to the community. Champions program is divided into 3 different sections, where either you can contribute as a moderator, where you can help us moderating the server, not just this Discord server, we have different communities out there, and either you can also help us hosting events like this, but those would be very specific to agentic AI and all of that. And the third way that you could contribute is that contributing to our open source repositories. And yeah, those are the 3 initiatives that we are driving at the moment. And if you folks are interested, you can join with us. And yeah, thank you so much. You can reach out to me if you have any questions about DevRev, how to use DevRev, why should you even care about DevRev. I have answers to all of them, so you can reach out to me. I'll be right there in the networking section. Thank you.
Hello, hello, hello. Check. Yeah, that was it. Hope you guys had fun. We had some great talks here today. I believe we have one last thing to do. Get together for a photo. So where do you guys want to do it?
Yeah, we will come forward and
Everybody.
We can do it here.
And yeah, the DevRev team will be here like for next half an hour. So anybody wants to stay back, catch up, we can talk about few things.